Hello, this is an additional video and an apology to Group 1 of the apprentices from this morning. There was something that was incorrect that I told you that I realised after you had all disappeared, and I just want to clear it up. It's with regards to your homework. A couple of things just want to say that I didn't say. Looking through my list of things I should have covered, there was a few things I missed off because, well, the nature of online, it's quite hectic actually. So a couple of things we need to label. On the left here would be A and B. Okay, now these are vertical forces. So as you can see, we've got 12 and 11 and 6 all downwards, and we've got the vertical forces upwards, designed to keep it in equilibrium. So we would refer to them as VA and VB. Now in the book, it doesn't go into this depth, but Josh Hobday is gonna take you to the next level with this, and Josh can be very posh Josh with his structural mechanics, and he's a stickler for his symbols and stuff, and rightly so. We've also got moment A and moment B, and the other thing we need to know is that this is negative because it's anti-clockwise movement or anti-clockwise moment, and this is positive because it's clockwise moment. So obviously we will have a rotation that way, clockwise, and that way, anti-clockwise. So those are just a couple of things that I wanted to add. However, the apology is not for that. The apology is for the UDL and the way that you use that. And one thing that I just absolutely blatantly obvious, which I didn't tell you, was that you calculate the UDL. Okay, so let's just highlight this here. There's our UDL. And we calculate that first. Because it's consistent, it's actually, let's get rid of what I've just done there. We've got UDL equals 6 newtons times 4 meters, which equals 24. All right. Now what we do is we disregard the UDL in this situation like this, and what we do is we take the dead center, which I told you, we take the dead center of it like that, and it becomes a point load. So the force of that point load is 24 over here, look. So we've got this here, and it equals 24 newtons. So now it becomes the same as, we treat it the same as that, and as that, as 11 newtons, 12 newtons, and it becomes a point load with a distance, because we've got 1 meters plus 2 meters, and then half of this distance, which would be 2 meters, and then likewise it'd be 2 meters the other side, but you don't need to worry too much about that. So if we take a look at that now, we will say that we can say that the right reaction, which equals moment around A, which is this one here. So you remember, if we're looking at the right reaction over here, then we're going to start with moment around A. We start here, don't we? So that would look like 11 newtons times 1 meter plus, now here's where it comes in, look, 24 is the next force along, is 24, because we converted the UDL into a single point load, which is straight in the center of the UDL, straight down the middle, and we calculated the total force times distance is 24. So the force is 24 newtons times the distance, which in this case is 2 plus 2 plus 1 equals 5, obviously. So 5 meters. Okay. And then the last force, which is the 12. So we got 12 times 13 newtons, 13 meters. And then what we can say is 11 times 1 is 11, plus 24 times 5, which is 120, plus 12 times 13, which is 156. That equals 286. Is that correct? No, 287. 287, okay, and we divide that by the span, which is 1, 7, 9, 11, 13, 14. So we divide it by 14, and that will give you 287 divided by 14 is equals to 20.5 newtons. So therefore the left reaction is equal to the total sum of forces, which is the VA plus VB. So VA plus VB equals, so the equal is, we've got 24, 36, 47 newtons. And we've just worked out this one, we've just worked out the right reaction, this one here, which is in the notes. So we've got, this would be a negative, by the way, negative 20.5, because it's anti-clockwise. Yeah, that's what we've just worked out. So the left reaction is about moment B. Okay, so equals moment B minus 20 is, sorry, here, get this right, which equals VA plus VB minus MA, or to write that another way, therefore right reaction equals the total sum of forces, which is 47 newtons, minus 20.5 newtons, which equals 26.5 newtons. Okay, and we can see that there's total sum there. If we add those two up, we could also say that VA plus VB equals 0, because both reactions add up to 0. The total sum of forces, the reactions, the vertical force A plus the vertical force B equals 0, because it's exactly the same as the force down, which is 47 newtons. Okay, now this is a video, so obviously you can go back to the beginning of this and go through very slowly, but my apologies again, the way I told you how to do it. It was just that bit there where I should have converted the UDL into a single point load rather than separating the UDL into two different distances, the way that and then said, well, you calculate 24 on the left and 24 on the right, which is totally incorrect, and my apologies again. So what I'm going to do now is I'm going to give you another set of homework. This is the one that I want you to work on now. So now knowing what you do know, okay, this is what the homework we're going to be doing when we come back after the half-term break. This is the question that we're going to start with. All right, so homework. Again, any questions, anything you don't quite understand, just message me, let me know. But this should clear everything up now, and to the point where Josh will elaborate this further in terms of exam style questions. Okay, thank you.